Welcome to the first in a series of lectures on the gas laws. For this section of lecture, make sure you have a pen or pencil and a piece of paper. You are not going to need your red, white, and blue periodic table for this. You are not going to need your calculator for this section. However, you are going to need your calculator all through the rest of these lecture sections, and you will, more than likely, I would keep your red, white, and blue periodic table handy with you. I would also have the mole map handy with you. As we go through this lecture, any questions you have on concepts or applications, please make sure you write those down. Hopefully by the end of this lecture, we will have answered those questions. And if we have not, please make sure that you address those with your instructor before going on to the other sections of this particular lecture. But feel free at any time to pause the video as must needs. I will also point out certain things that you need to make sure you know by heart. So please make sure that you write those down, or however you want to record that information, and make sure that you are studying these. The best thing I can tell you about the gas laws is practice, practice, practice makes perfect as you go through these. So you don't need new problems as we give those to you, but you do need to make sure you understand how to do the problems. So feel free to always go back over any of these lectures as they're available and run through them, making sure you understand the different gas laws as we approach those. Okay, so let's go ahead and get ourselves started. When we talk about gases, the behavior of gases, we said that gases can be related by temperature, pressure, and volume. Temperature, of course, we know is the amount of heat in something. Pressure is the amount of force on an area at sea level. So as we go through pressure, there are certain standards for temperature and pressure that we're going to talk about, which is called, strangely enough, standard temperature and pressure, that we'll be looking at, that you're going to need to make sure that you can recall and you memorize that information. We'll point that out to you. And of course, V is the amount of space occupied by something, because that is the volume of something. Okay, these are not terms that you found should be unfamiliar to you. We're just taking them, and now we're looking at the behavior of gases using that information. When we talk about volume of gases, the units that we use are very important. Volume of gases can be in liters, they can be in milliliters, or they can be in cubic centimeters, or any cubic measurement, which is considered a volume. Make sure that you are aware of the units for volume. If we give you volume in liters in a problem, and we ask you for the new volume or what volume it had before, make sure you give it to us in the correct units. Units are huge in this particular lecture. The number is fine, but if you don't have the unit correct, or even who it belongs to pretty much sometimes, then the whole thing is going to be wrong. So make sure you write down somewhere that volume is in liters or milliliters or cubic centimeters. Whatever we give you, make sure you give us back the same unit if we're asking for a change in that particular factor of volume. Pressure, there are standards at what we call standard temperature and pressure. When we look at pressure, we find that at sea level, and again, let me make sure I write that down so that you write this down, at sea level, okay, at sea level. Make sure you understand that. The atmosphere is 1 atmosphere at sea level, or 760 millimeters of mercury if we want to measure it that way. That's at sea level. The gentleman who used the millimeters of mercury, we gave credit to him, so his name was Mr. Torr. So we also use 760 torr. So whether you see 760 in millimeters or you see it in torr, they're pretty much the same. 101,300, which is 101,300 pascals, Mr. Pascal. We use his standard, but we actually call it kilopascals. And 14.7 pounds per square inch, which is something you'll often find for those of you who decide you're going to go diving or learn how to dive. That's a big one also. So these are our pressure standards. We also, not frequently, but we also use 29.92 inches of mercury on occasion. Anyway, you need to make sure that you know these pressure standards and you know them by heart. I recommend that you start memorizing them now. So write it down, pause the video if you need to, or take a picture of it however you want to record it, but you do need to know those pressure standards. For temperature, we look at temperature with degrees Celsius. So the freezing point of temperature is 0 degrees Celsius, and the freezing point of temperature in Kelvin is 273 Kelvin. Now you should have already been reminded that if you're trying to go from degrees Celsius to Kelvin, if you have the C, you add 273, and if you have Kelvin, you want to go back to degrees Celsius. If you have K, you take it away. But the freezing point, we use degrees Celsius and Kelvin. So if it's 0 degrees Celsius for freezing, then it's 273 for Kelvin for freezing. And absolute 0 is what we call 0 Kelvin. This is where all movement stops. At absolute 0, it is the same as a negative 273 degrees Celsius. Put a star or something. You can go no lower than 273 degrees Celsius and 0 K. You cannot go any lower in temperature. So if you get a number that is less than 0 K, that does not exist. If you get a number or you're given a number that is lower than a negative 273 degrees Celsius, it does not exist. The lower, you cannot do a negative 273.004. It is 273 degrees Celsius, period. It can't be 0.03 K, negative 0.03 K. It has to be only 0 K. That's as far as you can go. You can go no lower. I cannot impress this upon you enough because we are going to be giving you numbers that you're going to have to say, that number does not exist, but you have to know that. So make sure you know that absolute 0 is the temperature at which all motion stops. It is equivalent to a negative 273 degrees Celsius, and you can go no lower than that, okay? All right. The boiling point for degrees Celsius, you know by now, is 100 degrees Celsius. And if we put it in K, since that's degrees Celsius, we add 273, and that is going to be 373 K, okay? And then the rest of this, I think, is a little more review for you. Celsius, the symbol is degrees C. Kelvin, the symbol is K. Note here, we always use K when doing the math. Why? Because any number times 0, which is degrees Celsius, is going to be equal to 0. Can't use it. And any number divided by 0 is going to be what we call undefined. Again, can't use it. So we always use Kelvin when we do the math. So you have to know how to go between Kelvin and degrees Celsius. To convert Celsius to Kelvin, we add 273. Like the 27 plus 273 gives us 300 K. And to convert Kelvin to degrees Celsius, we subtract 273. Like the 300 Kelvin minus 273 gives us 27 degrees Celsius. So always remember then, if you have C, add 273. If you have K, take it away. Again, if you have C, add 273. If you have K, take it away. If you add 273, you're converting from degrees Celsius to Kelvin. And if you're subtracting 273, you should be subtracting from Kelvin back to degrees Celsius. That's a real big thing you need to know for the gas laws. So write this down somewhere, memorize it, keep it on hand. You're always going to need it. All right, so let's talk about standard temperature and pressure. Well, we know our pressure standards already. We said with pressure standards, you have the atmosphere is 1 atmosphere. We said it's 760 torr. It's 101.3 kilopascals. It's 760 millimeters of mercury. It is 14.7 pounds per square inch. And I even told you about the 29.92 inches of mercury, which you may see on occasion. You may not, but you may see on occasion. That's what standard pressure is. If you were standing at the beach here in Florida, because we are at sea level, and the beach was lapping around your feet, you would be at standard pressure. And since we generally deal with atmospheres, they're always going to tell you the atmospheric pressure is, okay, well, the atmospheric pressure is 1 when you're standing at the beach. Now, what is standard temperature? Well, standard temperature is the temperature at which water freezes. Well, we already know that the standard temperature at which water freezes is 0 degrees Celsius. And if it's 0 degrees Celsius, I have C, I add 273, and that is going to give me 273 K. All right. So we've given you the units for your volume. We've given you the standards for pressure, and those are the different pressures that you're going to come in contact with. And in temperature, we know that we deal with degrees Celsius and we deal with Kelvin. We know that absolute 0 K is the point at which all motion stops, and it can't go any lower than 0 K or negative 273 degrees Celsius. Make sure that you know this standard temperature and pressure right here. That's everybody put together right there for you. Okay? You are going to need this very much so as we go through this particular unit of the gas laws. Okay. If those questions that you had were not answered, please go back and rewind this video, go through them again. And if they're still not answered, please make sure that you address those questions that you have with your instructor before we go on to the next section in these notes. Have a great day. Bye-bye.